Good morning, students. This class we will discuss about what is Vernier Caliper. What are the parts available in the Vernier Caliper? Linear measurement is the distance between the two given points or objects. So Vernier Caliper is one of the linear measurement device. Is used to precisely measure linear dimension because here Vernier Caliper have two scales, main scale and Vernier scale. So Vernier scale it will give uh, to measure that precise and accurate of that particular component or objects. Next, we discuss what are the parts. One by one, we have to discuss. This is that main scale. Main scale is that large scale. This is that main scale. Uh, Runs along with body of that vernier caliper. So main scale is the large scale which runs along with the body of the vernier caliper. It is graduated either centimeters, millimeters, or inches. So depending upon type of units it's built for. So based on that experimental, what type of instruments you have to need. So based on you have to choose for that particular experiment. The main scale is stationary, so it's not like to move like that vernier caliper. This is that stationary. Next, vernier scale. This is that smaller scale attached to that main scale. This is that smaller scale, smaller scale. It will be attached to that main scale as the jaws are opened or closed. When you have to move the jaws, that time the vernier scale move along that left or right side. Vernier scale provides accuracy to the reading of the main scale, dividing lowest reading of the main scale. That here 50 divisions is available in that vernier scale. So this is that each and one divisions is have to split this much of divisions, 50 divisions. So it will be help to give that accurate value. Vernier scale is divided into 50, already I said earlier, 50 increments. So each representing 0.02 mm. So each and every uh, line represents 0.02 mm in this metric when we have to use that metric caliper. So representing 0.02 mm. Next, thumb screw. This is that thumb screw. So located at the bottom of the vernier scale to provide a grip for the user to slide jaws easily and adjust the position of the jaws. So it will be help to move that vernier scale. When you have to hold that object, that time you have to move to left and right. So thumb screw it will be help uh, to closely along with that objects. This is that main functions of a thumb screw. So lock screw. Lock screw is used to fix the position of jaws. Once you have to place that object between that two jaws, that time with the support of thumb screw, you have to move close along with that object. Then you have to tightly you have to lock that screw. Uh, Sometimes maybe you have to slip that component or it's not connected properly. We not take that expect or measured right values of that particular component. So the readings can be taken without the fear of spoiling that portion. So in this reason, we have to lock the screw once you have to take that measurements before you have to confirm. Upper jaws. This is that upper jaws. This is that lower jaw. This two is the lower jaw. Upper jaws are smaller in size and are attached to that upper portion of that vernier caliper. So used for measuring inside dimensions, hollow objects, inside diameter of pipes, length and width of the boxes. So how to measure that inside dimensions of that objects. Jaws are placed inside the place to be measured and open till they touch that edges and the reading is taken. So how to take that upper jaw and place it between that what type of objects you have to take. So you have to confirm once you have to touch that movable jaw in that upper position. So then you have to stop. Then you have to take that measurements of the particular component. Then this is that lower jaws. This is that lower jaws. Jaws are designed to grip objects family between for measurement. One of the jaws is fixed and attached to that main scale. This is the attached to that main scale of the caliper, while the other attached to the vernier scale. So this is that attached to the vernier. One is connected to that main scale. One is connected to that vernier scale to measure outer dimension of objects. This is lower jaws. It will be help to measure that outer dimensions and length with diameter of that objects. Next, depth rod. This is that depth rod. This is that built in that vernier caliper. A thin rod located at the end of that main scale, which can be used to measure the depth of holes or steps. So, depth rod is used to measure the depth of holes or steps. Edge of main scale is placed on the top of the surface. This is that edge of that scale. It will be placed at the top of the surfaces of the hole, and then jaws are opened. So jaws are moved from right side direction. The thin rod it will be come out. So you have to easily to measure that measure of the depth of holes or steps of particular objects. So this is that position. So the experimenter had to place that end of that here I mentioned here end of that main scale. Have to place it and have to move the jaw. The depth rod will go down. So you have to measure. So what depth it will be available on the two components. As the jaws are opened, the depth rod slides out within a main scale. Depth rod is extended till it touches the bottom of the hole and the reading is taken. Once you have to touches that bottom of that objects, then you have to stop to move that slides. You have to take that measurements. Now, so how to use that vernier caliper? Here, slide one of the jaws against that object. So, what type of component you have to measure? That particular objects have to place it fixed jaw and movable jaw. Read the main scale where it lines up with the sliding scale 0. Next, read that vernier scale. So, what lines it will be coincide with the vernier scale and main scale that values you have to take. Add the numbers together. Main scale plus vernier scale. This is the total reading of that vernier caliper. So, when you have to add at that vernier scale, it will be multiplied with that least count 0.01. So, this is that use of the vernier caliper to take that measurements. Now, so what is the least count? So, smallest reading which can be accurately measured with the vernier caliper. So, with the support of a vernier caliper, what type of measure you have to take a minimum, that reading is called as a least count. So, generally in that formula they are given. So, you have to calculate. So, least count of vernier caliper 0.02 m. That's why already we mentioned. So, each and every lines divisions have 0.02 m. Dividing the smallest reading of the main scale with the total number of divisions of that vernier scale. So one divisions have to split 50 increments. So this is that main scale. This is that vernier scale. So that the 0 it will be coincide with 19 in between 19 and 20. So have to take that 19 plus what type of values it will be coincide. Here you have to take. So 5, 10, 15, 20, 21, 22, 23. 23 into 0.02, so 0.46. Finally, have to add it main scale and vernier scale. So total measurement of that particular objects are 19.46. So that same type of procedures you have to follow and have to measure that particular component. Next, what is resolution of vernier caliper? So resolution is indicated at the end of the vernier caliper and it is the smallest distance that the caliper can measure. So with the support of instruments you have to measure that smallest value of that component. So it will be help to measure smallest distance had to notice in that instruments. So here 0.02 of resolution of the particular Vernier caliper. Here we have to show that 0.05. So depends what type of values you have to use it. Depends upon how the scales are divided. So based on that resolutions value, they are mentioned. So easily to identify what are the resolutions of instruments. Easily have to look at and find out that value. Then advantages of Vernier caliper. Vernier calipers provide accurate and precise measurements over a large range. So 150 mm, 200 mm long Vernier calipers are available. You have to easily to measure that linear large dimensions of component. To take a variety of different measurements, internal, external, and depth measurements. So the type of facility is not available in that micrometer. So in micrometer, if you want to measure that external, internal depth, you have to choose that individual. So the type of worry not about that vernier. So everything's available. You have to measure the outer dimension, inner dimension, and depth. So most of vernier caliper are made out of stainless steel. It's give good durable. With the proper care of stainless steel, vernier caliper can last a lifetime. It will be life was good because of we have to use that stainless steel corrosion resistance property have. So so more life. If have if that experimenter the persons have to use it properly. So to get more life of that instrument. Next, what are the disadvantages? Vernier scale of vernier caliper is quite small, so can sometimes difficult to read. So this is that one of the drawback. So not easily to look at that surface. I have to find out the value. So in micrometer, so thimble readings have to use clearly they are given. Have to easily to find out what lines it will be coincide. So that type of issues come under that vernier caliper. So good eyesight or magnifying glass is required when taking readings. So magnifying glass is available in that bevel protector. So have to easily to look at and have to measure that angle of the particular components. So the type of things is not available. So very closely have to monitor. And good eyesight it's need. Then only have to take that accurate reading of objects. Users must learn how to read vernier. So this is very important. So that the experimenters know how to conduct, how to take, how to interpret that coincidence, how to see that main scale reading and vernier scale reading. This is that based on that experience only, have to take that measurements without flaw. Thank you.